uh, we did all these things. We did also nuclear fission, life of stars, life cycle, supernovas, fusion. Now we will start today half-life. Half-life.
স্যার এটা বায়োলজির মতো শোনাচ্ছে না ওয়ার্ডটা।
Which one?
হাফ লাইফ।
Yeah, it's life is related to everything. Yeah, there is half-life also in physics. It's the half-life of radioactive elements. Okay, how long it will decay and how it's decaying. There is one rule to observe the decay. So that one we are measuring with half-life. So half-life is all the radioactive particles, they have radioactivity, right? And
ইয়েস স্যার।
they are emitting alpha, beta, and alpha, beta particles and gamma radiations. And by emitting all these things, they are losing their mass. You know that neutron is breaking down to proton, then some masses are converting to energy. This way their mass is decreasing, so the time it requires to get the radioactivity when their mass is decreasing, or their number of nuclei are decreasing, then their radioactivity also decreasing, right? Isn't it? Hello.
ইয়েস স্যার।
At the
ইয়েস।
beginning, the way we are getting alpha, beta, and gamma, when the radioactivity or the emission will become half, that one is called half-life. Half-life of the radioactive particle or radioactive nuclei. So we are going with that one. Can Ziva, can you read please from here in radioactivity, half-life?
In, rea- in radioactivity, the interval of time required for one half of the atomic nuclei of a radioactive sample to decay, change spontaneously into other nuclear species by emitting particles and energy, or equivalently the time interval required for the number of disintegrations per second of a radioactive material to decrease by one half. The radioactive isotope cobalt-60, which is used for radiotherapy, has, for example, a half-life of 5.26 years. Thus, after that interval, a sample originally containing 8 grams of cobalt-60 would contain only 4 grams of cobalt-60 and would emit only half as much radiation. After another interval of 5.26 years, the sample would contain only 2 grams of cobalt-60. Neither the volume nor the mass of the original sample visibly decreases. However, because the unstable cobalt-60 nuclei decay into stable nickel-60 nuclei, which remain with the still undecayed cobalt.
Okay, wait here. So from my discussion, whatever I said, uh, this part is saying the same thing, right? So here we will take this part. Look, the interval of time required for one half of the atomic nuclei of a radioactive sample to decay into other nuclear species by emitting particles and energy. The time required to become one half, like this one, cobalt 60. Cobalt 60, you are given 8 gram, and cobalt 60 will convert it to other elements, right? By emitting alpha, beta particles and gamma radiations. It will convert to other elements. So they are mentioning here, look, neither the volume nor the mass of the original sample visibly decreases. That means the other nuclei, when we discussed nuclear fission, we got uh, two smaller nuclei from the uranium sample, right? Isn't it? Hello?
Yes,
Hello?
sir.
Yes. So
Yes, sir.
we are getting the mass like before, but the elements changed. Elements changed. Our given elements was cobalt 60, but we will not get all the mass as cobalt 60 now. After 5.26 years, we will get only 4 gram of cobalt 60. Okay, so that's why it is called half-life. And the radiation or the emission of the particles, alpha particles, beta particles, or gamma radiation, that one will be also become half. Okay, if you are taking one Geiger-Müller tube and you are recording their, reading the emission of alpha beta particles and gamma radiation in the Geiger-Müller tube, Geiger-Müller meter, there we will get the reading, right? And before 5.26 years, the way you are getting, for example, you are getting 1,000. I'm giving just simply one example that you are getting 1,000 at the beginning, and after 5.26 you will get 500 counts per minute or per second. Is it clear to you? Hello?
Yes, sir.
Yes, sir.
Okay, on this part in half-life, do you have any questions? Whatever we discussed. Then we'll go to the graph to understand it.
Sir, basically the change is in the amount there is, not the mass of the cobalt
Yes,
60 or the atom.
yes, of course, sir. In cobalt 60 mass also there is change. Like you are getting there 8 gram of cobalt 60 at the beginning, but after 5.26 years there will be 4 gram of cobalt 60. But other 4 gram will be other. Cobalt 60 is converting to different elements, right?
Yes.
So those things are available here, but you in physically you will not understand it from outside because the amount of cobalt 60 is still more than the other things, isn't it?
Okay.
Is it clear now?
Yes, sir.
Okay. Any more questions, please? Azmain. Hello, Azmain.
जी सर अस्सलाम वालेकुम सर
Walaikum salam. Thank you for joining. Welcome back. Happy Eid ul Adha Mubarak. Okay. So, how was your Eid, Azmain?
सर great
Okay, good.
Assalamualaikum,
how
sir.
was your Eid, sir?
Walaikum salam. Aisha, how are you?
I'm fine, sir. How are you?
Alhamdulillah. Thank you for joining. Yakin Sajjad is coming also. What about Ifaz? Ifaz, I found yesterday he was very active to join the class.
Mhm.
He is still
He just asked for the routine, not for joining the classes. He just
okay.
wanted to see the routine.
Did he join in the first lesson?
No.
No, 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 no.
Okay, it will
No,
take
no,
some time
no.
because it's a long time habit, right? To rise early is a very tough job now, right? It's a
Yes,
challenging
sir.
job.
Extremely. Very, very.
It's challenging job because of the lockdown.
Mission impossible.
You have changed your routine. You have changed your habit, right?
স্যার রোজার 1 মাস রাখলে স্যার পুরোটা সারা বছরের জন্য হয়ে যেতে পারে এমন অবস্থা।
Okay. So
আমার বেশি এলোমেলো হয়েছে কবে জানেন স্লিপিং টেবিলটা রোজার পরের, কারণ রোজার সময় ঘুমাইতে যাইতাম তো একদম
আমার রোজার
মধ্যরাতে
টাইমে হয়েছে।
উঠতাম 1টা 2টার দিকে এরকম টাইপ
আমি
প্রবাবলি
তো ঘুমাইতামই ভোর 4টা
রোজার পরে একদম অবস্থা এই হয়ে গেছে।
Okay, can we continue the graph?
Yes,
If
sir.
Yes,
this
sir.
part is over, then we can continue the graph. You are getting the half-life questions every year. Every year we are getting either in numerical in MCQ part we are getting, or in structured part we are getting, or sometimes it comes in both places. So half-life is very important for you. Now Aisha joined late, Azmain also joined little bit late. Whatever you got, we will try to understand from this graph. Okay, then I think you will be able to understand. And we also have the recording. You will get all the things from the recording, so don't worry. Now look, we are given at the beginning, this is time, okay? Here, amount of radioactive material A compared to the original amount A naught, or any quantity which is proportional to A. So here we are getting time. This one T is showing you 1 half-life, and 2T is showing you 2 half-life. This way is continuing. At the beginning, there in our previous example we got cobalt 60. For example, you are given here 20 or 40. You take more because we are having here more half-life. So for example, you are given 40 gram. Here at the beginning, we are getting 40 gram of cobalt 60. Then after 1 half-life, how much will be? If it is A naught by 2, A naught is your 40 gram. Then
20
A
gram.
naught, yeah, 20 gram. The sample will be now 20 gram. This is
20 কেন ওইটা না 400 ছিল
না,
নাকি
it
নট
was
ওইটা?
40,
আচ্ছা এটা নট।
40,
ও আচ্ছা আচ্ছা ওকে
40 grams. So it is 20 grams now. Then it will, how come it will, how much it will be? 10
10
grams. Okay, then it is
5
5
then
then 2
5,
point something
2.5 2.5
and then 1
Yes.
point something. হ্যাঁ
1.25.
1.25.
হ্যাঁ then 1.25
2.5
Yes.
grams, then
1.25
1.25 শেষ
1.25. Not, it is not over. There will be another half-life. They are not showing you that one, but there
কই
will
স্যার
be,
সেটা দেখতেছি না তো।
it's not in graph, but you can divide 1.25 again, right?
Sir,
0.75
Yes,
না
0.
হ্যাঁ
0.75 or 0.725.
ওই তো স্যার হবে কি
0.725
স্যারটা
Yeah, 0.725. Yeah, maybe Aisha, right? Aisha was saying sir, or
not
Ziba.
like that.
Ziba.
Will this half-life continue till till there is no gram left?
Yeah,
Like
yes,
0 gram?
it will actually, there will be even little amount, but that action or that activity will be not felt,
Reaching
will be
0.
not felt by us. So that one will be very less until it becomes negligible. It will continue. We can't say zero. There will be even fraction, very small fraction, but that is negligible. We can say very close to zero, right? Do you understand what I'm saying? Yes,
sir.
even maybe
Yes, sir.
0.000000 after that 5060 then 1 gram. That still there is something, right? But that one is negligible, very close to zero. So which one is visible to us? Which one is in our physical appearance available? That one we are showing on. Okay. Then we can continue next. Do you have any queries here?
No, sir.
Now we are getting more discussion on half-life. Next. Here.
Sir, when will you give me my answers on MCQ, the
I gave.
corrections?
I gave.
Where?
Today you can check in the link. I posted in both the groups. Okay.
Correction to
So
MCQ.
yeah. In our physics group, I mentioned it that the MCQ answer is also available there.
Okay.
So you can have that link over there. Okay. Is
Okay.
it clear?
Yes, sir. Thank you.
Okay. Now a half-life. Can Azmain, can you read? You are our guest. After a long time, you
Yes,
are coming. You are host.
sir.
Yeah.
Yes, sir.
Continue
Uh,
here.
it is possible to find out the half life of a radioactive
মুখ
substance.
থেকে মাইকটাকে বাইক কর।
না আমার মুখ
Okay,
থেকে
let him
মুখের
let
বাইরে
him read. Let him read. No problem. We have also the material in front of us. We can also read, but let him
হ্যাঁ
read
নিজের
in his
মতন
way.
পর
Yeah. Continue,
Yes,
please.
sir.
Continue. Azmain
It
again.
is আচ্ছা স্যার It is possible to find out the half-life of radioactive substance from a graph of the count rate against time. The count rate drops from 80 to 40 counts a minute in 2 days. So the half-life is 2 days. Sir,
Yeah.
hello.
Continue. In the next 2 days.
Yes, sir. Sir, আমি দেখতে পাচ্ছি না ঠিক মতো।
Okay.
আমার নেটের সমস্যা আছে।
Okay. Is it now clear?
না স্যার আমার নেটের সমস্যা
Okay, fine.
ক্লিয়ার না
Fine. Now, Yakin, you continue here.
In the next 2 days, it drops from 40 to 20, it halves. In the next 2 days after that, it drops again from 20 to 10, it halves again, and so on.
Okay, this one you understand that it's coming from 40 to 20, then 20 to 10. It's very simple to easy. What I want to add here that we can draw the graph 2 ways. Here we see we gave the quantity like original amount A naught, right? That means how much materials or substance, radioactive substance we gave
Sir,
here.
half life শেষ হলে কি ম্যাটারটা ডিকে হয়ে যায়?
Half-life, already I told you that
ওইটা তো
actually
স্যার কখনো জিরো হবে না, তাই না?
yeah,
এক্সপোনেনশিয়াল টাইপ না, মানে
yeah,
হাফ 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 হইতে
yes,
থাকে।
yes. In theoretical point of view, if you think theoretically or mathematically, then it will never be to zero, but it will be negligible. Very small amount we will get. That one is not visible or detectable with us by us. But there will be some radioactivity always. Okay. Even it is very small fraction. Now what I was saying about the graphs, in 2 graphs we are showing 2 ways. Both are half-life graphs, but we are showing in 2 ways. So in your exams, in your assessment also you will get in 2 ways. Like here we are given amount of substance in grams, or we can mention that how much is given, like there is given 100 cobalt 60, then after half-life it will become 50 cobalt 60, this way. Okay, Do you understand what I am saying? A naught is the original amount of the given sample, or original amount of the radioactive substance given. And here we are showing the time, half-life. Each of the half-life we are showing. In other graph, Afraz,
Assalamu alaikum, sir.
walaikum salam. Thank you for joining.
Welcome, sir.
Okay, look, we
আজকে
are
দুইটা
discussing
ঈদের চাঁদ
half-life. Whatever you missed, you will get in recording. So just you try to be with us
স্যার
until the
আর কেন
end.
বললো ঈদের চাঁদ স্যার?
Okay, look, here we are getting this graph. They are showing counts per minute. Whatever I told you at the beginning, that we are getting alpha, beta emissions. Also, we are getting gamma emissions, right? Alpha, beta are called particles, and gamma is rays or radiations. That one we are getting, and it is detected by the counters. We are having lots of counters we discussed before. For example, we are dealing with the GM tube counter, Geiger-Müller counter, and in the counter we are getting this reading, counts per minute. Okay, the more you have the radioactive substance, you will get more emissions and you are getting more readings, right? Are you clear?
Yes.
So here at the beginning we are getting 80. Whatever the sample is given at the beginning, from there we are getting the counting, that is 80. And the counting becomes 40. When the counting becomes 40, the time required to become the counting 40, that is called half-life. Is it clear? Hello?
Yes, sir.
So half-life we can define in two ways. The first one is the amount of sample we are giving, radioactive sample we are giving, the mass of that sample is becoming half. That time is called half-life. Or the emissions we are getting from the radioactive sample at the beginning, when the emissions, number of counts or emissions are becoming half, we are saying also radioactivity is becoming half. That time is called half-life. So do you understand how to define half-life? Hello everyone.
yes sir
You can define in two ways. Now I want your feedback on these two definitions. Adnan will say me the first definition and Ziba will tell me the second definition of half-life.
স্যার মৌসি ফার্স্টটাতে শুরু করুক, সেকেন্ডটা আমি দেখা যাবে।
Okay,
এক
Moshi,
সেকেন্ড আসতেছি তাই।
he needs your help. Adnan needs your help. Can you help him? Hello? No one is.
Sir, আপনি আরেকবার বলে দেন।
Okay. Again, I am saying the
স্যার
first
একবার
one.
বলেন, কথা অনেক কাট শুনছি, অনেক
Okay, the first one I said. First one I said. Should I write here? If I write, it will be better for you.
yes
Okay, the first one I'm writing here. You see, the time required.
এই ডেফিনিশন কি স্যার জানতে হবে ও লেভেলস এর
Yes,
জন্য?
you have to know this definition. What I can say that you can make this definition. If you understand, you can make it. You do not need to memorize my wording or the notes wording. If you understand, you can make it. No problem. The time required to become the the mass of the given
আচ্ছা স্যার, আপনি নোটস গুলো যেগুলো পিডিএফ এ দিয়ে দেন সেটা আপনি একটা কাজ করতে পারেন তো, যেগুলো মানে নোটস আমরা খাতায় তুলবো সেগুলো আপনি একটু হাইলাইট করে দিয়েন,
yeah
হাইলাইটার দিয়ে।
I I did it.
ওইটা করলে
I
আমাদের
did
নোটস
it
তুলতে
with
সুবিধা না হয়, দেখা যায় যে
italic
কিছু কিছু
form.
তোলা হয়, কিছু কিছু এক্সট্রা তোলা হয়, কিছু কিছু তোলা হয় না, এরকম।
Yes, I did it in italic form. Some of the places which are we need to highlight. Okay, the time required to become the mass of the given radioactive sample to half. Okay, the time required to become the mass of the given radioactive sample to half. It is one example. Okay, another one, the radioactivity the time required making similar so that you can memorize if you want to memorize it easily. The time required to become radioactivity of a radioactivity oblique you can write emissions. Emissions you understand, right? What is emissions? Alpha, beta and gamma. Okay, that one is radioactivity of a given sample to half. It's the shortest. Okay, now this one I gave mass. Here also you can here I gave mass, right? Instead of mass you can also use instead of mass you can also use mass or number of nuclei. Okay, is it clear now? Hello?
Yes, sir.
Okay, so instead of mass we can also write number of nuclei. That one I wrote here. So if it is clear now you can tell me the two definitions of half-life. Adnan, you can tell me now the first one. You can make it by your own wording, no problem, if you understand it. Hello, Adnan? Adnan? Yeah, make it.
Minute
Mm-hmm.
and goal.
Hello, Adnan. The half-life is related to time, right? You start with time, the time required. Hello. Okay, then Adnan, maybe he has problem with microphone. Now, Aisha, can you tell me, Aisha?
Yes, sir.
The first one you tell me.
The time required for half of the mass, the time required for half of the mass of the matter to decay.
Very good, excellent. Now, Ziba, you tell me the second one.
the time required for the mass or number of nuclei of the given radioactive sample to half.
Okay, that one is the first one. The second one I told with the counts per minutes or emissions. That one you say.
Oh, sorry. The time required for the mass of the
Not mass,
uh,
not mass. The
number of
radioactivity. Yeah,
you wrote
number
that
of decay or
number of
emissions or
number of
radioactivity
or radioactivity to decay to
to
half
be half. Okay,
half.
very good. So you can make it. Now I think you understood how to, define a half-life. That's enough. If you understand, that's enough. Now this graph we are discussing. Look, here we got 40. So at the beginning, the count rate was, or the number of emissions, it was 80. Now it is 40. To be 40 is taking 2 days. The time is given in days. So its half-life is 2 days. Is it clear? This radioactive sample, its half-life is 2 days. So if they are asking you one question that when or after how many half-life the emission or the count will be 10, can you find it? After how many half-life the count rate will be 10? Hello, Yakin.
Ji sir.
6 days,
Yakin.
sir.
3.
After how many half-life the count rate will be 10?
So after
6
6
days.
days, right?
6
3
days.
half
Okay,
life.
we check it. We check it after how many days. I asked you about the half-life, not days. After how
Sorry,
Three
many
3 na?
half-life?
3 3 3.
3.
3 half-life. Yeah, your answer is correct. Yakin's answer is correct. That he is saying 6 days. That is also correct. But the way I asked, the appropriate answer should be 3 half-life, right? 1 half-life you are getting here.
For 1 half-life, we are getting 2. For 6, then
Yes,
we will
yes,
get 3 half-lives.
yes. Very good. We are getting 3 half-lives. In the same way, they can ask you after how many half-lives the count rate will be 2.5. After how many half-lives the count rate will be 2.5.
Sir, can you define what count rate is exactly?
Sorry.
Count rate, what is it?
Yeah, count rate means emissions, like you are getting alpha, beta, and gamma radiations, right? And you are getting their signal in GM tube or GM meter, Geiger-Müller tube. So that reading you are getting in the GM tube, that's your counts per minute. Is it clear now?
How do we define that using a graph?
Sir, for 2.5, we will get 15 counts per minute.
No, I asked you when or after how many half-lives the count rate or the counts per minute will be 2.5. That one was my question.
Oh, 5 half-lives.
Yeah, five half-lives. Now, Aisha, you got your answer. How you
So how
get?
do we use this graph to define this?
Okay,
I don't
Soon
understand
half
this
life
myself.
এরিয়াটা দেয়া আছে দেখ
okay. I am showing you. Thank you so much for your question. If you are any confusion, please ask me. Then I can answer. Yeah, look, the first half life is shown. The one Moshi was saying, right? Moshi. Hello.
Yes sir, yes sir.
Okay, thank you for your cooperation. Here is second half-life, because after 40 in second half-life it will become 20, right, Aisha?
Yes.
Then the third half-life it will become 10. So we are drawing graph from here, you see. Then it is coming here. Then after 10 it will be 5, right here in the middle, in between 0 and 10. It is 5 here. So we are coming here. Got it now, Aisha?
Yes, I got that. But
Yeah.
yes, I got that.
So it's
But
clear
how is
now.
it 3?
Is it
Or
clear
is the
now?
half-life 3?
So
Yes, that's clear.
half-life 3 this way. Look, 2 days we are having the first half-life. Then 4 days will be 2 half-lives. Is it clear? Then 6 days will be 3 half-lives. 8 days will be 4 half-lives. 10 days will be 5 half-lives. Is it clear
Okay.
now?
Yes, sir.
Okay. So today till this much, right? We are having less than 1 minute. So do you have
Okay, sir.
anything or any questions, please?
No, sir.
Okay,
Sir.
thank you so much. Thank you all for joining.
Bye bye, sir. Allah.
Allah
Bye
Bye
bye,
bye,
Hafiz.
sir.
sir.
Hafiz.
Assalamu
Assalamu
alaikum.
alaikum.